All right, I'll show you one example of a shelf break front. So many western boundary currents run along the shelf break. Okay, here's another example of a boundary current. It's the Lewin current coming around the corner. Okay, it's a map. Here's a map. Coming around the corner where the Cape Lewin is and flowing into the Great Australian Bight, coming into the Great Australian Bight. And there are measurements of the Lewin current just where this red line is. Okay, measurements, and that's just here above me. Temperature, salinity, geostrophic current. So temperature, salinity, again, you can see, it's warmer and it's lower salinity, the Lewin current, and you can see horizontal gradients. So let's have a look. Okay, you can see they're slightly offshore, but this is what we call a shelf break. Okay, shelf break front, where the shelf break is, you can see the shelf. This is where the current runs, and you can see in terms of the there's actually a method by which you can calculate the geostrophic velocity of these flows from observations of temperature and salinity, plus knowing what the shape of the sea surface. Okay, and you get almost a meter per second speed here. This is you can see strongest speed near the surface, and then the speed decreases with depth, sitting just where the shelf break. This is what we call a shelf break. Okay, and why it doesn't exactly sit over the shelf break is often related to the creation of eddies. Okay, because eddies make the front a little bit wider. Okay, let me see what comes on the next slide. It's another example, okay, of these shelf break fronts, and you can often see them in satellite images of sea surface temperature. This is the Great Australian Bight, late summertime. Red means warm, yellow means a little bit colder, white is cloud bias, some early satellite observations, and you can see the Lewin coming in, warmer water moving into the Great Australian Bight. But in the Great Australian Bight itself, there is a warm water current formed. Okay, you can see that warm water, and also moving along the shelf break. Shelf break can be a little bit, it's a very thin white line here, but anyway, you can see where the temperature changes. This is the density front, and it moves to the east. You can work out which direction it moves, stuff like this. It also creates a shelf break front. Very important feature. Okay, this is an example from the Great Australian Bight.